Hey, welcome back. This is Jordan Deshawn again here to give you an explanation of step 2 in the new pumped safe water design tool. So step 2 is about water supply, and the main question we're answering here is what water supply system is proposed to meet the needs of the community. Again, as a reminder, over here on the right side is an optional free space where you can enter your own notes or calculations. So feel free to use that here. On this tab, we're going to be entering water system characteristics. So the first question here is what water source will be used. And there's a drop down where you can select from this list. In this case, we've chosen a new borehole. You can also select others here for different projects. And as a reminder, if you select other, be sure to give a description of what the water source is here. But regardless of what you select, enter a description as well. Please note any concerns in use, ownership, seasonal changes in yield, quality. In general, this box is just for you to be as detailed as you can in your description of the water source. Next, we'll look at the water source yield. And the first question is, has a yield test been performed? Yes or no? Again, if you've selected no here, there's a box down below where you can explain why a yield test has not been completed. For example, if you're using a river with very high yielding water, you might not need a yield test. Or if you were proposing a new borehole that hasn't been drilled yet, then a yield test might not be used either. You can then enter the maximum yield and the maximum allowable abstraction. And you may have noticed as I hovered over this cell, we got a note that appeared. So any cells with a red triangle in the top right corner, you can hover over to read more about them. Next is water quality. So these cells here, there's a few that are automatically filled in: turbidity, bacteria, fecal, and total. And then there's others where you could select from a drop-down other water quality parameters. And the main ones we want to select or add on here are any that might be exceeding water emission limits. And again, there's an explanation box for if water quality testing has not been completed. Be sure to explain why and then when it will be done and any assumptions that are being made for the design since we don't know the water quality yet. There's this icon here showing a book that then links us to the reference tab. So for example, I'll just click this so we can see where it takes us. And we've been taken to step 2 where we can see the table 2.1 that shows the water emission water quality guidelines. So again, that reference tab as well as the optional calculators tab is here to help guide you through the design process. So let's go to 2C now. 2C is about water treatment. And the first question is if there's any pre-treatment required. You can select none or one of the other options here. Again, if you've selected other, always be sure to use the box below to provide a detailed explanation. The second question is around what water emission treatment equipment will be used. And the two that we mainly use are the erosion chlorinator, which on previous design tools might have been called the potable water chlorinator, or PWC. Now we refer to it as the erosion chlorinator, and the living water treatment system, or LWTS. For this example, they're going with the erosion chlorinator. And next is the question of what other water treatment equipment will be used, if any. In this case, we've selected none. And then in this description, it asks us to describe the proposed water treatment process, including pre-treatment and other treatment equipment. The water treatment equipment will include 2 erosion chlorinators operating in parallel. Pretty simple there. So step 2D is about water storage. And we ask the simple question, how much safe water storage will the project have? And they've chosen 20 meters cubed here. It's based on this general guidance to use 0.5 to 3 days of water storage. And if it's helpful, you could click this link to see an optional calculator about that. And finally, at the end of step 2, we have 2E, water distribution. We ask the question, how will the design population access water? And again, there's a drop down where you can select some here. As I've said already, if you've selected other for any of these, be sure to give an explanation of what the water distribution will look like or how the population will access the water. Then there's a way to define how many water access points or locations there will be, and then how many individual taps there will be. In this case, or faucets, in this case, there's 2 per water distribution point, so a total of 20 taps. And then this automatic calculation determines the number of people per tap by dividing the total population to be served by the total number of taps. And we get this guidance here that for community tap projects, Water Mission aims for no more than 250 people per tap or per faucet. And then finally, at the end of step 2, we get a summary of the key data points and outputs from step 2. So next, in step 3, we'll look at hydraulic design. But thanks so much for watching, and please feel free to reach out to a Charleston engineer if you have any questions or need any support using this tool.